we've actually started Unravel already, and what I want to do is start at the job level. So what we're looking at here is the Unravel screen, and we've actually gone into your log files and well, not your log file, but the log files for, like, say, the Spark UI and the Spark UI. Oh, a little bit of an echo there. I'm sorry. Anyway, so Spark UI and the Spark engine and other tools, sensors that we've deployed into the Spark applications themselves to really get a deeper understanding of the jobs you're running. So these are all the jobs that we've run on this cluster over the last 90 days, and we get a good mix of different types of applications we're running over, duration and read write times. So what I want to do is, as either a developer or as a DevOps person, is understand what's going on at a job level within these specific Spark applications. One of the things that I want to understand right away is basically, where my inefficient apps are. And so Unravel has the ability to quickly identify what those inefficient apps might look like. So I'm going to switch to this tab. So within the inefficient events, you can see here that we can isolate around the specific application type that we're using. And since we're talking about Spark today, we're going to actually focus on just the Spark jobs over the last 90 days. Now, what we've done is we filtered by the top 50 most inefficient Spark events. And what we can do here is, as a diagnostic tool, as a troubleshooting tool, is come in and identify specific, events that may have triggered the Spark inefficiencies. So some of the ones that we commonly run into are things like GC events or slow SQL operators or contingent drivers. Those are pretty, I don't want to say common, but those are some of the ones that we run into most often with inefficient Spark applications. So we can quickly filter to those specific events within Unravel, or we can take a look at the top 50 inefficient Spark events as a whole on this screen right here. What I want to do now is filter or sort by the insights that we're generating within Unravel. So I'm going to go ahead and click this and sort it. And so we have a couple different symbols that I'm going to call out. One is this kind of like looking 3 parallel lines with little dots on them, and those indicate specifically applications that have opportunities for optimization that Unravel has identified. The other little symbol, this little triangle with an exclamation point, is indicating that we've identified certain parts of the application that have failed. So obviously, an application that has opportunities for optimization and has failed a series is something of a pretty big concern. So let's go take a look at this Spark app. If we drill into here, what we discover is we have an out of memory error that occurred with this application. So to go along with that, we've identified 2 areas in which there are opportunities for efficiency. So one is around CPU resources, and then second one is around overall resource efficiency. So we've not only identified where this this Java memory error occurs, but we've also have recommended values to mitigate that error. So what I want to come back full circle to you folks and ask you guys is, when you have a Spark application that is either inefficient or has failed, like what is your your troubleshooting methodology to identify the root cause and then work towards a resolution for these applications? And so what I kind of want to get you guys to think about is, what does that look like from a manpower standpoint? What kind of applications do you have to go to get this kind of information around an out of memory error or a contingent contend to driver error, and then how do you actually go through the steps to resolve that? And what would it mean if you could identify all of those errors on one interface, and then also get recommendations on how to fix that or even optimize your application? So this is really Unravel is really kind of bringing all of this information into one spot, and giving you a significant opportunity to improve your mean time to resolution. And I can speak directly to this because I have a couple customers that have come to me and said, they have to involve like 2 or 3 engineers to do the root cause analysis. It usually takes them a couple days to identify what the problem was, going through lots of like log files and the Spark UI and whatever other tools they have to do the root cause. But then they also have to identify how to fix the problem. And so that's it's a lot of manpower that's could be used in more efficient ways. And so this is an opportunity. Unravel brings this all in one spot, and so you can quickly root out these problems and get to your resolution in roughly 1/10 of the time. And so what does that translate into dollar wise? So that's a great way to think about where this would be helpful. Other sources of information that we can get within Unravel is your resources. Like how many containers is this job using, or how much memory are they using? So these are all metrics that are available within Unravel. And normally, if you didn't have this kind of tool, you'd have to go to 3 or 4 different places to get things like CPU load or Java memory, heap sizes and whatnot. So this is a great way to kind of get all this information in one spot and get your team to collaborate to work towards a resolution much faster. Okay. Let's take a look at another application here in which we actually had some success, but there's still an opportunity for optimization, which you see with these little lines right here. So within this application, this job actually ran successfully, but we identified some things that some opportunities within Unravel to kind of take a look at where you might be able to speed up the application. And within EMR, you're being charged by the second for any time that you're using the cluster. So any way that you can make an application faster is money in the bank. And then you extrapolate that over thousands of jobs and over a year. I mean, that tends to really add up. So let's take a look at a couple of these bottlenecks here. We've got a slow SQL stage, a bad join, a contended driver. And so, Unravel is very intelligent in the way that it, comes in, takes a look at the application as it's being run in real time, and then identifies these opportunities to make improvements. Okay, and scroll down. We have a contended driver, contention for CPU resources. So these are again ways that you can improve efficiency and then not only identify what those issues, those challenges are, but also make recommendations around how you can improve those. Okay, so I've shown you a couple different things at the cluster level. So let's expand out our scope here. I'm sorry, I've shown you things at the job and application level. So let's expand outside of just the job level here and take a look at it from a cluster perspective. So I'm going to switch screens and come into this next screen here at the cluster level. So one of the other challenges that we've seen with customers is they don't quite know what's running on their clusters from an application perspective or from a user perspective, and then how to charge that back to the BUs or to the users or to the cluster or what's going on. And so Unravel again has a very granular way to break down the costing, because as you know, it's like charging by the second will become very critical to understanding how to best maximize and optimize your cluster usage. So what we've done here is we've taken a look at the cluster from a cluster name perspective, but you can also come into Unravel and take a look at it, from a cluster as a whole. So we have a breakdown of the cluster IDs on our EMR cluster. If you want to take a look at it from the release level, you can break it down by the release level as well, and you can take a look at the granularity in which we can break down the cost structures. But for today's demo, we're going to take a look at it from the cluster name. And when you look at the cluster names, you can see we've identified a number of different clusters here, and you can see that the usage in which they're being used. And so obviously, like our machine learning cluster here dominates almost over 50% of the cost in the cluster, followed by the data science cluster, and then the upgrade test cluster. And so you can not only break it down by the average cost, but you can also take a look at it from the overall cost as well. So if I want to take a look at how much cost is used by data science and by the upgrade test, I can see all that information that broken out by total cost as well as average cost. Now, these little graphs are nice, but being able to kind of see the data behind that, we can take a look at it from a cluster name as well. So we can see, here's that machine learning cluster, here is that data analytics cluster, and we can see, the breakdown by costing and the number of clusters involved. So you can see it what the EC2 cost might look like, what the EMR cost, and then kind of what your storage costs are, and then what these total up. And so, this is a pretty finite breakdown of how you're using your EMR cluster, and this is something that you can get through a number of different reports within EMR, but being able to see this all in one interface and being able to associate the jobs that go along with these specific clusters is hugely helpful. And that, so if I were to take a look at this data analytics cluster, and I want to get more information about what jobs are actually being run, I just have to click on that, and I can see the actual applications that are being run on the cluster and what they're being used for. Okay, so let's take a look at this data analytics cluster in more detail. And what I'm going to do is I'm going to click on the insights. And so the insights that you see here are similar to the insights that we already saw at the job level. So information about what the challenges were with being able to bring that information into the forefront. So let me switch screens again. And we're going to go to okay. So nope, I apologize. I got the wrong screen here. Let me switch back. And yep, this one. Okay. So back on track, and I apologize again. So what we've done here is we've gone from the cluster level information about that 4722 cluster, and then we've drilled into the insights around that specific those specific applications. So one thing I want to point out is within this data analytics cluster, we have recommendations at the cluster level. So what we're saying here is, due to the instance type that that was originally assigned, which is a R5X large, based on the actual running of the jobs here, we're suggesting that maybe a different instance type may be more efficient, for the jobs that are being run. And so that's what we have here, and that's what we've identified. And so and then we have roll up of the cost savings that are potential with these specific with these jobs based on instance types. Okay. More information we can get here around the applications themselves within this cluster is we can actually break this out into the jobs that are being run in these applications. And so it's going to switch screens again, and let me grab this one. Yeah. Okay. So so now what we've done is we've come full circle from a cluster level and looking at it from a chargeback report perspective into the cluster itself, and now we're looking at it from the actual job perspective. So we've drilled top down from the cluster into the applications, and so these are the actual applications that have run on that 4722 cluster. And we can see again, what there are opportunities for improvements at the job level. So we've already made suggestions for improvements at the cluster level. Now we're going to do that in more detail at the job level. So if we're to drill into this information around inefficient apps, let me go back to the beginning of here. Yeah. So if you can look more at these app efficiencies again, we can take a look at these jobs. And so similar to what we saw before, we have some SLA improvements by changing the value of the Spark, the memory settings for the executor, and the memory overhead, as well as here we're showing that the CPU usage is pretty low, and so there's a way to kind of make improvements there on this specific job. Okay, and please, if you have any questions, type them out in the chat, and then we'll get to them at the conclusion of the presentation. All right, so now we've taken a look at opportunities to where Unravel can improve cost and efficiency from a cluster level and from a job level. The next thing I want to look at is taking a look at it from a dashboarding perspective, and how you might be able to take advantage of some of the technology in Unravel to kind of understand it from a higher level than from the cluster. So let's go to that screen next. All right. So we'll come into here. And so what I want to show you here is this is our new value dashboard. So this is a way to come into Unravel from a top level and identify where there's opportunities to improve efficiency within a dashboard. So the user here might be someone that's more at a management or executive level, but they want to understand what the cost profiles look like, where get a real quick understanding of where their costing might look like, and where there's opportunities for improvement. And then also resource efficiency. So, how many failed apps do you have? How many total apps have run in that period? And out of those specific applications, which ones are the most compute intensive or the most memory intensive? Because again, this could translate into ways that you can get a better understanding of how applications are running in your cluster. And then from an app perspective, we have those optimizations that we've talked about from the beginning, and being able to to make recommendations about improving the efficiency of the app with respect to speeding up your applications. So that, again, that translates into seconds or minutes used on the cluster, which directly relates into your cost profiles, as well as any auto actions that we might be recommending for jobs that are taking too long, or if there's any inefficiencies in your SQL statements. So join keys or join conditions are identified as well under the app acceleration. Okay. So one thing that I kind of talked about for a second here is around auto actions. So another thing that makes Unravel unique, in addition to the optimizations and recommendations that we can provide around your applications and your clusters, is around auto actions. So let's dig into that a little bit more. So what we have here is our auto actions, and these are ways to proactively have Unravel identify what where there might be some inefficiencies in your applications, and then notify your IT organization either by email or a post, or if you have an ITSM system, like ServiceNow, we can tie directly into those ITSM applications, so that people are notified right away if an application fails, or if an application is running too long, beyond a certain amount of time or days. Unravel can identify those, because we're hooked into those jobs at a very granular level, and then proactively notify your IT organization around those applications, so that you don't end up wasting cycles and time and money around those inefficient applications. So if we were to drill into these, this application a little bit more, we can take a look at the auto action here, and it basically, what it says is, if any of the applications exceed a certain allocated memory consumption, or a certain app count, to go ahead and proactively notify the IT organization around those events that happen. Okay. Same thing here for any kind of compute that's a threshold that's being exceeded, or other or maybe a queue exception. So in some cases, we can actually go in and instead of notifying the IT organization, we can come in and actually kill the app. So if it's a long running app, or if it's an app where it's just a runaway process, you can with the right permissions, you can go in and actually proactively kill the app with Unravel, so it doesn't continue to chew up resources. All right. So let's come back out of auto actions now and take a look at we're going to keep leveling up and take a look at this from an overall cluster perspective. So this screen that we're on now is another dashboard, and this dashboard really encompasses the whole EMR cluster as a whole. So all the different job applications that are running can be seen right here. But really, you kind of want to get a broad understanding of what's going on with your clusters. We're going to take a look at it from all clusters, and you can see some metrics. So from a compute perspective, from a memory perspective, and from a node perspective. So this is a great dashboard for anyone who's in the DevOps team, or someone who wants to understand if there's any thresholds that are being exceeded, or what's the overall health of the cluster. So we can take a look at what those peak values are pretty easily, as well as from a node perspective, as well as a compute and memory perspective. So we can understand what's being spun up, what's being spun down, and how they're being used. So this is from a cluster perspective in the top half of the page. The bottom half of the page looks at the applications specifically, and around those applications, what the current state is. How many do you have running? How many were successful? How many were failed? How many were killed? So this is a great way to kind of get a very quick understanding of what's going on with the applications within the cluster. And then, you can also see where your inefficient events are, and what those are related to. So it looks like we have a lot of, in this case, we've got a lot of Hive, jobs that are running, TES jobs that are running that are not very efficient. So you can identify those very quickly within Unravel, and then troubleshoot them from here. The next step I want to take a look at is around what's actually being used from a resource perspective on the cluster. So if I go to the next tab over, we can see in a more granular detail what's going on with respect to the compute here, as well as it breaks it down by application as well. So we can take a look at the volume of jobs that are running. So what this screen is really helpful for is understanding what's going on with the resources relative to the actual applications that are running. So here we can see there's a peak in compute and memory usage, which also correlates with a peak in the applications that are being run. So in this case, we have 600, almost 800 applications that are being run on September 20th, and so we can say that there's a correlation between applications and jobs run. Now, what's great is I can come into Unravel and filter that specific peak and take a look at that in more detail. So I can say, okay, well, within what's going on at these specific times and these specific days, to kind of really get a better understanding of what's going on with my cluster. From here, what's really helpful for a DevOps person or even a developer is if I said there's a peak at this point, I want to understand what jobs are actually being run in that specific with that specific application type. So I can click on this graph and then get those specific applications that were running on this job. So one thing that I kind of want to ask you guys as you're looking through these different screens on Unravel and how and what kind of information we can get for you. How are you doing this now? How are you correlating peak usage of compute and CPU to the jobs that are actually running at this point? And then are you easily able to identify which jobs are running at that specific time point to understand what's going on with the cluster, if there was a resource contention, or if you were running out of your resources as a whole? How do you identify that? How do you troubleshoot it? And then how do you resolve those inefficiencies? And so these are all really good ways in which Unravel has built this application to really help out your IT teams, your DevOps teams, your data ops teams to understand this data and get it into the right hands as quickly as possible. All right. From here, one other thing I want to show you is our workload information. So if we were wanted to understand what our workload looks like over this time period that I performed my analysis, let's say I'm going to come from July to November. I want to understand how many jobs have been run, and what have I done with those jobs over that time period. So I can see in September, on the 23rd, 353 jobs were run, and on the 20th, there were 501 jobs run. And this is kind of interesting to see from a cluster perspective, is understanding how the cluster is being used by the days in the month and from historical data. But what's more telling is when I break it down to hours by day. So what this heat map shows us is how many jobs have been run on Sunday through Saturday. So days of the week are on the y-axis, and then the x-axis is times of the day. So what this reveals is that Monday through Saturday on this cluster at 9 a.m., there's an increase in jobs that have been run on this cluster. So this may make sense from the perspective of people come in at 9 o'clock and start kicking off jobs, but what's going on here at midnight at Monday through Thursday? This is a great way to understand. It's like, okay, well, maybe I don't know what's going on at that time, and help understand what jobs are being run. Are these jobs that can be spread out over different parts of the week to lower the overall resource consumption. And so right now we're just looking at it from a total sum, but if we look at it from an average, we're going to see a pretty similar profile on the heat map usage. So Wednesday at midnight, there seem to be a lot of jobs that are run, and so maybe you can spread that out over maybe 4 p.m. on Friday and Saturday where there are no jobs being run, and that will lower the overall resource consumption on the cluster as a whole. So this is I have a lot of customers that come in to this heat map, and really it's eye-opening for them because they didn't realize that's how the peak usage was being used, and where those when those applications are actually being run. We can also take a look at this from, well, I don't have an Impala in here, but if we had Impala, we would see that as well. So it would be really useful on this page if we could maybe identify what jobs are actually being run at this time on Wednesday at midnight or on Monday at noon. Well, I can do that. I can do that here with Unravel. I can quickly click on that cube within the heat map and understand that there are 141 TES jobs, or there's 58 MapReduce jobs. And so now I understand better understanding of what's happening at Monday at noon, but two, what those specific application types are. And if I wanted to get more granular, I can actually go out and find those specific, in this case, MapReduce jobs that are being run at Wednesday at noon, and I can take a look at what those jobs actually are, and then what the parent app is. So this is Hive on MapReduce, and then any insights or tuning suggestions that Unravel might have. So again, this comes full circle again from a cluster level down through an application level and into the understanding of where that brings us on at the actual the tuning level. Okay. With that said, we are about 20 minutes left to the session, so I definitely wanted to leave this open to any questions that I can answer. So let's go ahead and do that, Marissa, if we have any questions. Marissa, can you hear me? Can I hear me? Can you hear me, Marissa? Oh, I can't hear you. It's weird. Is there a chat? Oh, here's a chat.
You hear me now?
Oh yeah, there we go.
All right. So we did get one question.
Okay.
The question is, one question so far, rather. The question is, does Unravel work with other cloud platforms?
Yes, that's a great question. So I realize that you're all here to talk about Amazon EMR today, but yes, we absolutely have integrations into GCP as well as Microsoft Azure and Databricks as well. So Databricks on Azure and Databricks on AWS as well. Yeah, great question.
All right. And then the second question that did come through is, can I use Unravel if I have Databricks?
Yes. Yes, the answer is yes. So because Databricks is very Spark focused, all the functionality that I kind of showed off today with Amazon EMR, you can also get that exact same functionality with Databricks as well, and probably actually not probably, but yes, there's actually a little bit more functionality because Databricks is very DBU intensive. So as opposed to Amazon, which is, they charge by the time, Databricks charges by the DBU, and so we're very sensitive to that. We have a lot of customers that are very sensitive to the DBU usage, and so they're looking for ways to optimize their Spark jobs to minimize their DBU throughput. Yep.
Great, thank you. And the last question that we have here today, so far at least, there is still time to drop your question in the questions box. The last question here is, we are not yet on the cloud. Can Unravel help with that?
Yeah, absolutely. So Unravel's Genesis is actually on-prem Hadoop. So we have a pretty strong presence in that space, and so because that's where we came from, we all the functionality that you saw today with respect to Spark optimization is available on on-prem world as well. And then if you saw within the applications that we looked at today, I know we only talked about Spark, but we also have the ability to do similar analysis for Tez, for Impala, for Hive, for MapReduce, and so all of that understanding of the way that your applications are running and ways to optimize. Those are all available on those other technology platforms and on-prem. To go along with that, because we're Unravel, we also have the ability to understand how the cloud migration might look like. So if you're looking at moving from on-prem Hadoop because let's say your end of life for Hortonworks, or your end of life for CDP, we have tons of customers who are coming to us and saying, like, what do we do now? And so we can not only help you optimize your on-prem and prepare you for the migration into cloud, but we can give you some analysis around what the cost might look like, what that migration strategy might look like. If you need to re-platform, what's the best technology to re-platform to? If you're running on Tez or Impala, some of that stuff doesn't migrate very easily, and so we can make recommendations using the Unravel tool, for you from an application standpoint, from a cluster standpoint, and then because we're cloud agnostic, again, we can make recommendations on all the major vendors, and so you can make a decision on which route you want to go.
Awesome, thank you.
Yeah,
that was very informative.
Cool.
And let me just check the questions one more time. Nope, I believe we've covered everything.
Awesome.
All right, so those were all the questions that we had today. And like I said, this webinar is available instantly on demand, so please share this link with your colleagues or peers. And if you are watching on demand and want to ask a question, please email us at hello@unravel.com. And again, we value your feedback, so please share your thoughts by rating this webinar and let us know if there are other topics you'd like to hear about. Of course, I'd like to thank Mike for sharing all of this knowledge today and for your time, Mike. We do hope to interact with all of you in the audience at a future webinar, so keep an eye out on the next one. And thank you, everyone. And with that, Mike, do you have any closing thoughts?
No, just come out and see more webinars, and we've got a whole optimized webinar series. So if you have questions around Spark specifically, or Google Data Proc, or Microsoft Azure, feel free to drop in and take a look at some more of our webinars. And thanks, Marissa.
All right. Thank you.
All right. Bye, guys.